Harbour Prime Industries, I'm working on a project specifically around controlling carp, specifically through biological control, and that's part of what I'm here to talk with you about today. In the time available, I'm going to keep this a bit short. There'll be some things that, of course, I won't be able to cover, but I'm really happy to have a chat with you afterwards. What I'd really like to talk about whilst I'm here is some of the management options that have been employed to try and control carp over the last few decades. The progress, how are we going? Specifically, I want to move on and talk about carp biological control, because that's, of course, what I'm working on. And last, a couple of the more commonly asked questions that we get, that we encounter in pest species in Australia. That gives us the ability to consider some really courageous management approaches. Why do people dislike carp so much? Well, they're ecosystem engineers. What that means is they shape their ecosystem in ways that benefit them and happen to disadvantage our native species. You've heard some fantastic presentations already today about our beleaguered native fish communities. Carp are part of the problem. They're not all of the problem. They are a part of it. And the problem trend, it extends beyond an ecological issue. It's also an economic and a social issue. So there have been a couple of attempts at trying to estimate the economic impact of carp in Australia. The highest of those was at about $500 million a year. Now, whether it's 5 or 6 or 4, the take-home message is it's a big figure. And that the Australian community dislike carp and would like to see this species removed or at least significantly reduced in their abundance and their impact in Australian waterways. We have some approaches that we can employ. And one of the other reasons why they dislike them so much is there's just so many of them. They make up 80% of the fish biomass in the Murray-Darling Basin and up to 93% in some areas, which is absolutely staggering. Not sure what happened there. Okay, so we've got a few control measures that we've been employing over the last couple of decades. I'll move through this fairly quickly. To anyone who's not familiar with what that is, that's a carp trap. It's a beautiful, elegant Aussie innovation which exploits the fact that carp jump and native fish don't. So basically, if presented with a barrier, carp will eventually try and jump that barrier, and in the context of the carp trap, they end up in a cage, and the native fish don't jump, and so of course once the cage is lifted up, the native fish can swim past. Beautiful little, elegant Aussie innovation. In some places these will catch and harvest up to 5 tonne of carp in a day. But there are now a number of them that have been employed throughout the Murray-Darling Basin, and across all of those, so about a dozen or so. And when you compare the catch rate across all of those structures, the average catch per day is about 1.4 carp. So ecologically insignificant in terms of delivering a landscape scale reduction of the impacts of carp, but still a pretty useful tool as part of the arsenal that we have available to us. Commercial fishing today remains the most effective way we have to control carp. You can say one thing about our commercial fishers, they are extremely good at catching carp. There's a couple of reasons why commercial fishing will never be the solution in terms of controlling carp in Australia. Number one, if more than 2 tonnes of carp hits the Sydney fish market's floor in a single week, it crashes the price. Our fishermen can fish to price, of course. They fish to market. So why would they ever land significantly more than that amount if it's going to mean that they take home significantly less? The second problem is, if they actually did significantly increase the amount of carp that they were putting on the market floor, and they dramatically impacted on the availability of carp, of course it then costs more per carp to continue to catch carp in the system. There will become a point where it is commercially not viable to continue to catch carp. So part of the solution, but not the solution in itself. Judas carp, obviously this is a technique that's employed on terrestrial pest species as well. You can't really see too well, but this little guy's got a radio transmitter in its stomach. So you put a radio transmitter in a carp and let him go, and he swims back to his school, and you can target the school fairly efficiently. Fantastic in places like Lake Sorell and Lake Crescent in Tasmania, where there was a small population that needed to be mopped up, but in terms of fixing the problem in the Murray-Darling Basin, probably not too effective. Sex pheromones. So obviously, female carp can give off sex pheromones, which attracts males. We can use that to increase the effectiveness of traps. An interesting part of a tool in the arsenal. Behaviourally, interesting trait between carp and native fish is as water levels in a wetland drop, carp will move deeper into the wetland. Native fish will pick up on the cue and leave the wetland. It gives us the opportunity to modify water levels in wetlands to strand carp, which is fantastic. But again, in terms of the biomass of carp in the Murray-Darling Basin, which is estimated to be somewhere up maybe 7 million tonnes of carp, probably not the solution. And community carp fishing events. So recreational fishers love coming down and being part of the solution, bringing their family, and they can have a fantastic weekend. The data shows us that they will actually extract less than 4% of a population in those events. So not the solution itself, but what a fantastic way to engage the community in pest fish control. And there's genetic techniques. So this isn't actually a carp at all, it's a zebrafish. There was a technique which has been a lot of research done over more than a decade on daughterless carp, essentially modifying the genetic makeup of carp so that they only give birth to male offspring over time. That will of course modify the ratio of sexes in the population and so the productivity of the population. Fantastic, but a lot of money had been invested in this and the results were a bit slower than they'd hoped, so the funding dried up effectively, and so this research is still ongoing, but over in the United States it may still be some time away in terms of cracking that particular piece of technology. So every time we do field work and we end up in a restaurant and a pub at the end of the night, we get asked one question universally, which is, what are you doing about the carp and are you winning? Well, if I was to give us a report card in terms of our progress over the last couple of decades, I'd say it would be an F. And to echo the voice of my Year 4 maths teacher would be, tries hard, but hasn't really achieved desired results. Still stings. Anyway, so why am I being so harsh? Well, consider this. Over the last decade, whilst all those measures were being employed at a cost of several millions of dollars, the abundance of carp in the Murray-Darling Basin has increased fourfold, according to Sustainable Rivers Audit data. The national range continues to expand, and under climate change scenarios, there's a lovely map which basically shows there's not a single place in Australia where there's water that carp wouldn't be able to persist. So the problem we could expect to get worse, and every time we do surveys we're finding carp elsewhere. In fact, the problem is getting worse. And we heard a bit about environmental water. I need to make the point that any time water is delivered down a river over the bank, it can create a spawning event for carp. And in fact, we've got some really interesting data on when water is held artificially onto floodplains to provide outcomes in terms of red gums and nesting water birds, and it does, by the way. It provides fantastic outcomes in terms of helping those components of the communities. But there are winners and losers, and carp are winners in that process. This is actually a sample taken from a single floodplain habitat after an engineered flooding event. Really, you can't see the species, of course, but that's just hundreds and hundreds and hundreds of young of year carp at a density of up to around 1 million fish per hectare. Really significant spawning event. Really what I'm trying to say is we need a new approach. What we've been doing hasn't been working, and biological control gives us some options there. So we've got a virus, which is, as I mentioned, is an exciting prospect for biological control. It was discovered in the late 90s. It's now found in over 33 countries around the world. It results in a very high mortality of carp, between 70 and 100% of a population of carp that haven't experienced this virus before, and it only affects common carp. So in terms of answering the first question that we get asked all the time, it is, how do you know this is going to be safe for other species? Well, the CSIRO have been doing research funded through the Invasive Animals Cooperative Research Centre over the last 8 years. And it's been enabled us to confirm that this is a safe option for non-target species. There's two reasons for that. Number one, this is a DNA virus. You know that old thing, valvoline oils ain't oils? There are two different types of viruses, DNA viruses and RNA viruses. RNA viruses are quite unstable, they mutate quite a bit. DNA viruses are quite a bit more stable, and the bigger their molecule is, the more stable they become. The cyprinid herpes virus, the virus we're talking about, happens to be the largest molecule DNA virus that's ever been described. It's quite stable. In addition to that, carp are actually very, very distantly related to any of the native species in Australia, which is great, because we know the number one most important characteristic in whether there is a risk of jumping to a non-target species is whether they're closely related. There are no closely related species in Australia. I'm going to move really quickly through this, except this slide is all to demonstrate the fact that carp are very distantly related. So the green one here is Cyprinidae. The only closely related order of fish is Siluriformes, this red one here, which is catfish. We've tested 2 species of catfish. They could have actually just tested catfish and determined, yeah, this is safe because it doesn't affect catfish, but they didn't, CSIRO that is. They tested representative species of every order of fish that occurs in freshwater and estuarine habitats in Australia that co-occurs with carp, and basically found this virus will not replicate in any other species other than carp. It will certainly not cause disease in species other than carp. In addition to that, they tested example mammals, example reptiles, example amphibians, crustacea, and example birds. So you can see what they're trying to do. They're trying to test species that might encounter this virus in the natural environment. What they found is this virus will not replicate in any species other than common carp. They didn't really expect that it would because it's a herpes virus. They tend to be very, very species specific, but it's good to see the research confirm that. Okay, the second question, is this virus safe for humans? The answer we can derive from the evidence overseas. Remember, this is a virus found in 33 countries around the world. The answer is yes. Number one reason for that is there is not a single example of any fish virus in the world ever causing disease in humans. That's a good start. In addition to that, this virus, bearing in mind carp is one of the most aquacultured fish in the world, this virus is present in carp farms all over the world. People have had a close physical contact with this virus over several decades now without a single reported case of an itch or a rash or a single human health issue. In addition to that, in places like Indonesia, which is a large producer of farmed carp, as soon as their carp start to show clinical signs of this virus, the first thing they do is kill them and send them to market. There are literally millions of infected carp being eaten for breakfast every day without a single reported human health issue. And of course, I whiz past the fact that they actually tested lab mice as an example mammal species and the virus wouldn't replicate in mice. Okay, so the third question we get asked is, how can you be sure that you're going to kill a lot of carp? There's a lot of carp out there, you're going to kill as close to all of them as we can. So how can we protect water quality? It is a very important question. But we have some really important case studies we can draw on from internationally. This is Lake Biwa in Japan. It's 14 times the size of Sydney Harbour. They lost 70% of their carp population in 2 weeks. I'm not saying the clean-up effort wasn't significant, but given the human resources they had to apply to it, they actually fixed the problem in 2 weeks. The scale of our issue is going to be significantly larger, but we can learn a lot from what works and what didn't and make sure that we develop a system. What we have as a benefit that no other country has is an ability to put an X on a calendar and say, that's the day when we need to have our resources mobilised. And of course, at the end of the day, fixing this problem is all about an appropriate level of resourcing. We're also doing some research, basically setting up little mesocosms and then applying differing levels of dead biomass of carp to understand where are the thresholds beyond which we actually achieve, we deliver poor outcomes for water quality that we actually need to avoid, and then we can try and manage the system to avoid those thresholds. We're forming an all-jurisdictional expertise working group to not just look at the issue with respect to the cleanup, but all of the technical issues associated with this, to really make sure that we do this right. And that'll have expertise in virology, epidemiology, fish ecology and biology, human health, economics, and all the rest. And like I said, this is all about resourcing. Like any problem, it's just making sure you've got the appropriate amount of humans and level of investment to do it right. We have a couple of really great things working in our favour. Number one is this has captured people's interest in such a significant way. A media release went out in January, first week of January, which got picked up by 250 media outlets as far as afield as the United States and China. And what that did was really demonstrate that this is an issue that's important to the Australian public. And so, basically shortly after, just quite recently actually, there was the announcement of $15 million of funding. I need to make it clear that that money is to ensure that we are prepared if we get approval to release this virus. It's not to do the release, it's not to do the cleanup. Those resources we will need to secure in time. So where are we at? We still have a long way to go. This is about 2 years off. Why is it 2 years off? Well, we need to achieve approval under 4 key pieces of legislation. That process takes 2 years. We are just submitting the applications now. So the earliest this will occur is late 2018. There's monitoring already underway, but to develop a baseline to understand what the health of our ecosystems look like. So monitoring native fish communities, carp populations, macrophytes, little bugs that live in the water, and turbidity. So we expect all of those things to change once the carp are significantly reduced in abundance. We need to undertake a robust risk assessment process. That'll be something that will be delivered through the $15 million that's been allocated by the federal government just recently. We need to undertake a national public consultation and education process. That's another deliverable under the $15 million. It's a very expensive activity, but it's absolutely vital. If we don't have social licence and the support of the Australian community, this won't go ahead, no matter how robust the science is. And of course, we need to develop the release strategy. How do we release this virus to maximise the impact on carp and minimise risks? We need to develop the cleanup strategy. How do we do this to get the fish out of the river, maintain water quality for human use and for native species? Okay. I need to make one final point. We get asked a lot, is this the silver bullet? Is this the thing that's going to do it? The answer is, it is as effective as this virus is, no it's not, and nothing ever could be. This is a map of control of rabbits. I put this up because it illustrates an important point. You can see right here, so rabbit plagues were absolutely just going crazy somewhere, what is that, 1930s. Then they released myxomatosis and they crashed the population. Then the population started to come back. Then someone had a bright idea and released the rabbit fleas, which increased transmission in arid areas, crashed it again. Then they released the Khaleesi virus, and somewhere around here we're looking to release an accelerated strain of the Khaleesi virus. It's only through an integrated pest management approach that you can achieve an outcome. We need to do the same thing here. We cannot be seduced into the idea that this virus will fix the problem. Lee mentioned all these wonderful things we can do for native fish. And we actually need to see this as a springboard to be doubling down and increasing our level of investment and focus on recovering native fish populations and secondary measures to control carp if we're going to get the outcome that we're looking for. But the benefits are significant. This is a place in Madison, Wisconsin. That's an enclosure where they got rid of the carp from inside the enclosure. You can see the change in turbidity. They ended up on the basis of this little pilot study undertaking carp control in the lake as a whole and significantly reduced the population of carp in this lake by 90%. The entire lake changed in turbidity. It became clear, people came back to fish and to swim. They'll do that in the Murray, they'll do that in the Edward, they'll do that in the Murrumbidgee, the rivers right throughout the Murray-Darling Basin. You will expect to see changes, maybe not in all instances this significant, but certainly positive changes. But we all need to work together to enable this to happen, because we've never seen a pest intervention measure of this scale in Australia. It's one of the biggest initiatives in the world, and so it'll take participation of community groups and CMAs and Lions clubs and private industry, all levels of government. And so we really look forward to working with the North East CMA and other partners as we do this. Thanks very much for your time.